Hi, I'm Mike Thompson, and in this video I'm going to start to talk about my CNC that I'm creating. Right here I've got my L298N dual H bridge stepper motor controller that I unfortunately blew out on day one. I ran too much current through it. I thought that with what I was supplied in my starter kit that everything would work out fine. Well, it didn't. And so I have begun to, I already ordered a new L298N. And you can see there maybe that there is a nice little chink out of the front of my chip there. Well, that thing one day just popped and started smoking, so I knew that was the end of that. There was no way to really desolder these all at once. My desoldering braid and stuff didn't work. I don't have a great soldering iron, so I just cut the pins off, and now I can do the desoldering one by one. So I'm going to go ahead and start doing that. And then I'll show you, we're going to solder this back up. Hopefully my new stepper motor will be in soon. You've probably seen the video of the single stepper motor test going back and forth. Disregard this. This has to do with my hot wire foam cutter power supply. Not really related to this. Although this CNC will probably be applied to foam cutting in some way or another, so that might still apply. But I'm going to go ahead and show you how we're going to fix one of these. Thanks for watching. Okay, my soldering iron is sufficiently heated. I'm going to go ahead here, now that I've got the chip out, I'm going to go ahead and clamp this into my little helping hands here. And we're going to go through with this desoldering braid. And the way you use this, in case you haven't ever used one before, is you simply hold it over your connection, heat it up, and since it's made of a very finely braided copper mesh, the solder is going to wick itself into the braid. In between the layers. I'm sure you've seen things, I mean that's how paper towels and things like that work. Just capillary action right into the braid, and then once this part gets saturated with solder, you simply move on down the next part. There's 5 feet in this little roll. Radio Shack had it for 4 something, I think. It should last me a really long time. So what I'm going to do now is simply go down the 2 rows of pins. We're going to desolder each one at a time, and then we're going to pull them out. We'll pop the new chip in, and we'll solder those up. So I'm going to go ahead and get started with that. Okay, I got everything all cleaned out. I had to ream the little holes out because they still had little traces of solder in them. I put a short length of a paper clip that I cut off into my Dremel. I'll show you right here. Essentially made a little, not quite a drill bit, but a sufficient reamer, I guess. So what I did was after I reamed out all the holes, I went ahead and screwed my new L298N to my heatsink. The heatsink is soldered to the board, and this single screw here holds the back of the chip to the heatsink. I went ahead and screwed that in because that guarantees that my pins all come through the same amount and just like they were before. So I'm going to go ahead now and solder each of these 16 pins in, and hopefully everything will turn out just fine. The one thing I forgot to do was put flux on my pins. It's going to make it a lot easier, so I went ahead, took the screw out, and I'm going to just dip the ends of my pins here in my paste flux here a couple times. I didn't see them have liquid flux in like a squeeze bottle. This paste is okay. I definitely prefer the liquid flux because this is kind of a mess to work with. They say it's no mess, but that's kind of part of the problem. You can't spill it or anything, so it's hard to put onto components. So I'll show you how this works. So I've dipped my pins in flux. I'm going to just line it up with these 16 holes, and it pretty much drops right in. Then I take my little screw, line it up with the hole in the heatsink, and pop it in. Well, if you get it lined up right, it'd go in. But anyway, that's all there is to that. Let me get this set up here, and I'll get to soldering. I'll be right back. a little better. The screw pretty well keeps the L298 in place, but the solder certainly helps. There we go. Much better. I've got my L298 in all soldered in place. As you can see right here, it's all hooked up. I got it to my Arduino. It's running to pins 6, 7, 8, and 9. I've got my little battery adapter here that I run to a little container that actually holds 4 AA's. So I'm not actually using 9 volts because it won't. My stepper motor only takes 3.4. So what I've done is these are about to go dead. So I've just put a wire in one of the sections there, and that'll give me the 4.5 volts. So I'm going to go ahead, plug this into my computer, upload the code, show you how it works. On the floor here, I've got my single axis CNC testing setup. My second stepper motor is not here yet, but it should be any day now. So as you can see right here, I've got my stepper motor duct taped to the ground. It's a NEMA 17 stepper motor. I've got a little bit of duct tape on the shaft, which attaches then to my 1/4 inch threaded rod. The threaded rod is 5 feet long, which will give me plenty of movement. The y-axis one will be 5 feet long as well. So then in the center here, I've got a piece of cardboard that just is keeping the threaded rod off of the floor for just whatever one thickness of cardboard is. That way it smooths out the rotation. And right over here I've got my little carriage that I've made for testing purposes. It's got 2 nuts embedded in it, one at this end, one at this end. And then as the shaft spins, this little carriage just goes back and forth. I've got the whole thing set up against a 4-foot ruler across the back to allow me to judge position accurately. So far everything is working well. I'm going to go ahead and turn this thing on now and show you how it works.